We're studying IGCSE physics and we're starting electricity division 3. Now to recap, Lula, tell me, what did we study in the last class?
In the last class, we studied about currents and the charge, mass, electric field, and gravitational field. We learned about the electric field patterns, and yeah, we did about the patterns. And for today's class, we will be learning about measurements of current, voltage, and resistance.
So current, to measurement of current. Did I give you the formula?
Yes, you gave us the charges. A equals to C by S. Current equals to charge by time.
Charge by time. Now, okay, perfect. Let's write it here again. Now I want you to write it one more time. We're doing measurement of current, right? And we'll start voltage and resistance. Let's see. The first thing first you need to realize is, what is measurement of current? Well, how do we measure current? That's the big thing. How do I measure current? Well, current first is measured in, what is the unit for current, Diana? Unit for current, Diana.
A,
which is amperes. We don't say A, we say amperes always. There's nothing called A. It's always amperes. We write A, that's the symbol, but we don't say A, we say amperes. Now amperes, it has the symbol A. Fine. Okay, and please write the equation one more time, which is charge is equals to current divided by time. That's fine, that's the word equation. But how do you write the symbol equation? The symbol for current is I. What is the symbol for current? So we say I is equals to Q over T. Time is T, Q is charge. Just a second, this is wrong.
Sir, what's the full form of I?
There's no full form, it's a symbol. The symbol, by the way, the equation is charge by time, not current by time. Charge by time. I is the symbol for current. There is no full form for it. Just but unit is amperes. Okay. Now I want you to memorize this. I is equals to Q by T. Q is always going to be charge. Charge. And I is always current. And T is time. Now, why are we using this? Why are we not just saying A? A is equals to C by S. Well, because those are the units. Those are not the symbols of these guys. So ampere is a unit. Ampere. A. Now, ampere is the same as coulomb per second. Coulomb per second. Let's write the symbols for these. A is amperes, and coulomb per second is basically C by S. But these are the units, they are not the symbols. Okay. Now next thing, we're clear with this. This was just a recap from the last class. Next thing is, how do we measure current? How do we measure current? Finish writing, everyone. Tell me when you're done. To measure a current, let's first have a circuit right here. In this circuit, we'll have a battery. We'll have anything which uses up current, let's say a bulb that must use a current. So this is our circuit right now. We have a battery and we have a bulb. But how do I know how much current is flowing in the circuit? What I'll do is I'll add something called an ammeter, which looks like this. So let's write here, make this a diagram and write ammeter. Ammeter is a device or apparatus used to measure current. Below it, write one more thing. Always connected in series. Diana, how much have you written?
I'm drawing the diagram.
Now, if I want to measure how much current I have in this bulb, how much current is coming to the bulb, I'll connect the ammeter right next to the bulb. So that will help me realize how much current is passing through. That ammeter will give me a reading. The reading in the ammeter will always be in terms of amperes. So ammeter gives the reading in amperes. The symbol for ammeter is a circle with an A. That's it. You can connect it any way you want. Not in anywhere, you have to connect this in series. What does series mean? We'll look at that in a few seconds. Now, before that, let's look at another thing, which is right, that's done. Now we know how to measure current. That's perfect. Next thing we have to look at is what is voltage. There's one more thing you should realize, which is what is a galvanometer? Basically, apparatus used to measure small current.
Is it something related to galvanizing?
No, it's just a cool name. They wanted a cool name and they got the cool name. So measure small current. Ammeter has a range. You'll have to set the range, but importantly, if you want to measure very small current, you have to use a galvanometer. Next thing is voltage. So Maya, are you writing?
Yes, sir.
Any questions?
No.
Voltage. Rana, can you hear me?
Yes.
Assalamu alaikum. Welcome to class.
Good evening, sir. Sir, I'm sorry I didn't enjoy before the class.
Okay, why not? Why were you absent?
Sir, I was left. That's why I didn't enjoy the class.
But you have a timetable. You don't have to sleep. You have to check the timetable and wake up on time. Is that clear? Okay, moving on. Join on time.
Okay, I'm not gonna do this again. Sorry.
It's okay. Now we'll finish. Everyone finish writing. Just a second. I'll open the book for you. Now, can you see the book?
No, sir.
No?
Now, yeah, we can.
Now you can't. So we have done all of this. Induction is done. Electric field is done. Look at the patterns. We have done all of these patterns, right?
Yes, sir.
Yep. Next is current circuit. We made the circuit. Single cell, wire, ammeter. We've done ammeter. We've done lamp. We've done switch. Measuring current is by using ammeter. Now, all right, there's one thing you should write. Write this in your book. Before voltage, write this. Rule. Current is same in all, or let's say, in series. Just write it and tell me when you're done.
Done, sir.
Now we have done this. Current is charged by time. In symbol, it is I is equal to Q by T. That's perfect. Now, next thing is current direction. We know current is always positive to negative. That's done. Now, potential difference. What is potential difference? Lula, read the objective.
Objectives to explain what is meant by.
Just a second. Read.
Objectives to explain what is meant by PD and EMF, to know the role of the PDS around a simple circuit.
Circuit. What is a circuit? Circuit is basically what we're drawing right here. This whole thing. That's a circuit. When you use a wire, these are wires. Okay. This is a bulb. The big thing with the X is a bulb. This is a cell. If you have two of these, that will become a battery. And we need one more thing in every circuit, which is a switch. We need a switch. This is a switch. I have a circuit, that's fine. The whole thing is called a circuit. Circuit can be of different types. You can have ammeter, you can remove ammeter. It's basically using wire to connect things together. Now, what is voltage? Before we look at voltage, let's call this part of the chapter potential difference. What is potential difference? Well, potential difference is basically, okay, let's see. Now, if I make a circuit for you, right here. This is the circuit. I'll have one thing here. Let's say I'll have something called a resistor. What is it?
A resistor.
Resistor. Now, R-E-S-I-S-T-O-R, resistor. Now, this is a symbol for a resistor. I'll give you a list of symbols later, but a rectangle like this is always a resistor. I'll add one more thing here. Let's say a bulb. Let's remove the resistor for now. Now you have bulb. And I also have a battery right here, a cell. And I have myself a switch. Now this switch is going to help me. When I connect the switch right here, the whole circuit will start, the bulb will light up, right? Because the switch has to join together. So if I connect it like this, then the circuit is on. But if the switch is open, then the circuit is off. You see? So it must be connected together. Now, next thing is, okay, we have a circuit. What do we do about this? If I close the circuit, let's close it. Now this will the bulb will light up, fine. And I realize that electricity is flowing from where to where. Current, Luna, tell me what is the current direction?
The current direction is negative to positive.
No. Najla, current direction?
From positive to negative.
Positive to negative, always. Now this is where my current is flowing. From positive terminal, current direction is positive to negative. Conventional current direction, which is positive to negative, always. Now fine. What is the electron direction, Diana?
Negative to positive.
Opposite, so negative to positive. So I realize that the electrons are moving from negative to positive. Fine. Like this. They're moving in the circuit, by the way. I'm just showing the arrow. So electrons are moving in the opposite direction to the current. So if I make an electron right here for you, this is an electron. The electron is moving like this, right? It's not just one of these, there are hundreds of these. So we'll have so many of these. And what happens is these guys will move like this. Is that clear? Any questions?
No.
Now, if they're moving, fine, they move like this. Good. Now, so what? Well, what we realize is, how are they moving? Why on earth are these electrons going from negative to positive? Don't you guys ask that question? Or don't you think that if it's, well, it's happening, but why is it happening? So the question is, firstly, the first question is, why are electrons moving from negative to positive? Or let's just say, why is current flowing? Why is there current in this? The answer for these questions is going to be because there is a potential difference. What is it?
A potential difference.
Potential difference. Because if you have a potential difference, then you'll have current flowing and you'll also have your electrons moving. Now we realize, okay, what is a potential difference? What we realize is, you should know, if I have, let's say, electron, okay, and I have a positive plate here, what will happen to the electron? Will it go away from the positive plate or will it get attracted to the positive plate?
Gets attracted.
Attracted because opposites attract. Unlike charges attract, like charges repel. So since unlike charges attract, what happens is this will get attracted to the positive plate. But okay, fine, that's what's happening. Let's change it a bit. Let's say you have this wire. Okay, this is the wire, and there is one positive thing right here, and electrons are in the wire. Now, where will the electron go, right or left?
Left.
No, that's away from the positive charge. Will they go left or will they go towards the positive charge?
It will go towards the positive charge.
Towards the positive charge. Let's write it here. Now, all of you should draw all the diagrams and write everything I'm writing in your notebook. That's important. Very important. Now, okay, we know unlike charges attract, like charges repel. So Maya, read the rule right here. Now, it's going to attract, fine. Now tell me, if I make it something like this, if I make a circuit like this, I had another electron somewhere here, okay, right here. Now, can you tell me where will this electron go, Lula? Up or down? Upwards or downwards?
Upwards.
Now, upwards is again away from the charge. Electron wants to go towards the charge, right? So it will actually go towards the charge, towards the positive charge. So if electron is here, it will go here. If it was here, it will go here. So all the electrons want to move to the positive charge. You understand? All the electrons want to move to the positive charge. Now they'll always take the path of, write the rule right here. Rule. Electrons take path of least resistance. Always take path of least resistance.
Sir, can you show me the writing that's under the diagram?
Sumaya, can you hear me? Najla,
Yes, sir.
read the first, read this rule right here.
Electrons always take a path of least resistance.
What is the meaning of resistance? Look, what that means is they want to move the shortest distance. Now tell me, what is easier? If for this electron, would the electron go from all this way from, let's say, will the electron go the whole way around it or will it go just directly towards it? So if the electron was here, will the electron go full way around the circuit and come here, or will it go directly to the circuit charge there? Tell me.
It will go
What do you think
directly
is
to the
easier?
positive charge.
Right now, if it was here, will it go like this or like this? Tell me.
To the right side.
Right side. That's easy. So what is easier? It will take the path of least resistance. Fine. So we know that. But what if I tell you that right here, I break the circuit? Okay. Now, one thing we need to realize is where do the electrons come from? The electrons come from the negative terminal. We have something negative, and electrons come from there. So these electrons, they come from the negative thing right here, and they go to the positive terminal, right? Now, if the negative terminal is here, they will directly go to the positive terminal, right? Because that's the shortest path from here to here. Then we'll have another one. Now, Diana, tell me, where will this go? Right or left? The second electron over here, this one.
To reach faster?
Yes, to reach the positive terminal fastest.
Right.
Right. Okay, so another one went over there. Now, where will this guy go? Najla,
Yes, sir.
where? Okay, Najla, I think you have answered. Sumaya, can you hear me?
Yes, sir.
So this electron will go to where? Okay, the electron wants to go to the positive terminal, so it will go directly to positive terminal like this. Any questions? But
No.
we can have a problem. We can have a problem. What is the problem? The problem is, what if my circuit looks like this? Now I had the positive terminal, negative and positive terminal. Or let's say if my positive terminal is here, and if electron was here, Lula, where will this electron go? Right or left?
It will go
To reach
towards
the
the
positive
positive.
terminal. So like this or like this, left or right? Which is easier?
Go left.
Left or right? So that's fine. Now what if I remove this from here? Now how
Then
can
it has to
electrons
go,
go to the
it
positive
has to
terminal?
take the long way.
There's no other way, right? They can't jump.
Yeah.
It's not possible. If it jumps, then it will tara bye bye, right? Goes away. We can't get it back. So for it to go to the positive terminal, it will go from here to here. Does that make sense?
Yes.
Now, okay. Now this right here is called a vacuum. What is it? It's basically, let's say there is a gap. Or let's just call this, there's an insulation here. Do you know what insulation means? Or what is insulated?
I don't know.
Like
Insulated
radiator.
is something that does not conduct electricity. Is that clear?
Yes.
So it does not conduct electricity. So electricity cannot move like this. It can't go directly from here to here. So it has to go directly from here. Fine. Now that is why it's going from negative to positive. So we understand the direction now. I hope that's clear. The direction is going like this, and it's not going directly to the positive terminal. But another problem is, what is causing these guys to move? What is causing these guys to move? Well, that right there is potential difference. Now, what is potential difference? Potential difference is basically if you have two charges, okay? If you have two charges, then the negative charge will go towards the positive charge. They're going to attract. So if I have negative terminal right here and I have these electrons, they want to go to the positive person, the positive terminal. Now this push, or what is pushing it? Well, this electron is pushed by something called the potential difference. If I say that this side is also negative, will the electron move? If this side is also negative, the electron will not go anywhere. Does that make sense? But if I make it positive, now there's a difference. What is the difference? There is a difference of charge. Is that clear?
Yes, sir.
Yes,
Now that
sir.
is causing the electrons to move because they want to go from negative to positive. Now this force is called the potential difference, and we can measure it in another way. Now if let's say if you have a box right here, okay, and Najla, if you push the box, does it take work, or do you have to do some work to push the box?
Yeah, it needs force.
It needs
You need
force.
some force, you have to do some work. So if you push the box, it will take some work. In the same way, for this electron to move, some work has to be done. What has to be done?
Work.
Now that work is done because of the potential difference. Who does the work?
Potential difference.
That is the thing that is doing the work. All right. So fine.
Does the potential difference does that so the electron doesn't lose its value?
The potential difference is basically like a hill. Imagine you have a hill. Okay. If you have a hill like
Okay.
this, an electron is here, and right here he has some food on the table. Let's say shawarma is there. Will the electron, or let's say not electron, let's say Lula is right here, and there's a hill. Would you go to the shawarma right there? Well, forget the
Obviously.
hill actually. You'll go to the shawarma right there. Let's forget the hill as well. Now what? Okay, that's happening. You want to go to the shawarma. Good. Now that, in the same way, electron want to go to the positive terminal. Fine. And but let's realize one more thing. It works like this. Now to go to the positive shawarma, you have to walk, right? You have to do some work.
Yeah.
You can't just magically appear over there. So that work is being done. Are your legs doing the work?
Yeah.
What is doing the work in the case of electrons?
Potential difference.
Potential
But
difference.
does potential difference is it found when every electron needs to be moved?
It is when you have a charge difference. What is it? Charge difference.
So if there is more than 2 or 3 electrons moving that same direction, will there still be a potential difference?
I'll tell you. We'll talk about that. Firstly, write the definition of this. Now we need to finish this as well. Now I like to teach everything in a lot of detail, but we also need to realize that we have to finish this quickly. Please write this quickly. Potential difference is basically voltage. What is potential difference? Name of
Voltage.
voltage. Another name of voltage. And what is voltage? Voltage is basically, or potential difference is work done over charge. Work done over charge. The equation for this is right here. V, let's just say V is equals to work by, or I'll write the whole thing for you. Potential difference, or we say PD, is equals to work done over charge. Najda, are you writing? Sumaya, can you hear me?
Yes, sir. I'm happy.
Jana, are you understanding?
Yes.
Work over Q. Now V, the symbol for V is V is V. Now one more thing you need to realize, I'll give you another symbol right here. Charge is in coulombs, work is in joules, and PD is in volts. Just a second. Write all of this as well. These are the units which I'm giving you. These are the symbols. There's a difference. So therefore, I can also say the unit for this is going to be potential difference. Right below potential difference, write the unit as well. Unit is V, volts, which is V, or joule per coulomb. Joule per coulomb. Now quickly finish writing this and tell me when you're done. Well, how do we get joule per coulomb, Diana?
What?
How do we get the joules per coulomb as a unit? We know it's V, V is written there, volts, but how do I get this?
No answer.
Now, no. Now, Diana, look at, you can answer in the chart, Lula. Now, Diana, what is the symbol for work done?
Joules.
Joules. And what is the symbol for charge? Or not the symbol, the unit for charge?
Coulombs.
Coulombs. So if I had 5 joule per 2 coulombs, what will the answer be? 2.5 joule per coulomb, right?
Yes.
Do you understand how we get it now?
Yeah.
So it's basically joule divided by coulomb, that's units, which is the same as volts. So volts is equal to joule per coulomb. Now, write this quickly. Tell me when you're done. Yes, yes,
Done.
Lula, you're correct. Done. Najla, have you
Yes,
finished?
sir.
Rana, have you finished?
Yes.
Yes, sir.
Sumaya? Sumaya, have you finished?
Yes, sir.
All right. Now, fine. We know what all of these are. Perfect. Okay, I have to tell you one more thing. Else? All right, yeah, this one. Look, now when you have 2 plates right here, what have we seen? If I have, let's say, I have this wire. Okay. Now, if I have this wire in the middle, I have 2 plates. Over here, I have plus charge 3, and over here I have negative charge 4. Or let's say I have okay. Now, which side has more charge? Tell me.
Negative
The
sign.
negative side.
Negative side. All right. Now, what we need to realize is look what happens if I go to the other side. Well, what we really try to do is we'll do one more thing. Look, this side has 2 negative. This side has 3 positive. Now, we have 2 sides here. Let's say side 1 and side 2. Okay. Now, how can I make them balanced?
If they're neutral,
By
How can I
adding
make them?
electrons.
Okay, adding electrons. Now, one thing is I can move any of these charge to that side, or I can move these charges to that side. I can only move electrons, by the way, not the positive charges. Electrons can move. So what
So
should
we
I do?
can
Should I take electron to the side, or should I take one to the side?
we should take
From the
one to the other side.
One to the left side.
Yeah.
So I take this guy to that side. Now, is it balanced?
Yeah.
yes.
Yeah.
Yeah. Now, okay, that's what's happening. Now, if I remove the negative charge, positive charges, and let's keep it like this now again. I want to balance it. What do I do?
Take one electron to the other side.
Other side.
From the
Yeah.
right.
Now it's balanced. Perfect. Now, if I remove all of these, now there's no negative there. I have 4 positive and negative here. How do I balance it?
We take two to the other
Take
side.
2 to the other side.
Take 2 to the other side. Now it's balanced. Now I want you to imagine this as the positive terminal and negative terminal. Now, whenever you have a battery, what it does is basically, why are electrons moving? Electrons are moving because they want to go over there and they want to balance the charge. Right? Now it's balanced. Now tell me,
Yeah.
firstly, to balance, electrons are going to go there automatically. You don't have to do anything, they'll go directly. Now they're balanced. Now, if it's balanced, now will the electrons go anywhere?
No.
No, because they don't want to change. They want to be balanced. So they
Yeah.
will not go anywhere. Now, fine, that's what's happening. If I remove this in the middle, and if I connect a circuit like this, I have negative charge here, 4 negative charge. Let's say 2 negative charges. Okay, how can I balance this?
I'll take one to the other side.
So now it can't jump like this because there's a
Yeah.
gap. So the only
We'll
way
take the
is go
long
like
way.
this. Now is it
With the
balanced?
help of potential difference.
Right? Now potential difference. Now is it balanced?
Yes.
Now will the second one also will this electron go over there?
No, it won't.
Because it wants to
Why
be
not?
balanced.
It won't be
Wants to be
balanced.
balanced.
It's already
Won't be
balanced.
balanced. Already balanced. Right? That's what we want. Now I want you to imagine the same thing for electrons. This side is negative, that side is positive, this side is shorter. Now this attraction, this push to go there and balance the other side is what causes electricity to flow. Now we don't have just one, we have hundreds of these. Look, we have so many of these. Now what happens is all of these guys will keep going to the other side until they are balanced. What will happen after some time? After some time, they'll become balanced, right?
Yeah.
Yeah.
Now, if these are balanced now, the battery will stop working. So let's write it in scientific words now. Over time, what this means is, okay. Now, since these guys are here, what do they have over here? They have something called potential energy. What do they have?
Potential energy.
Potential energy. Let's write it over here. Potential energy. Okay. Now, when this electron goes from here, let's say this whole thing goes from here to here, it loses the potential energy. What happens? Loses potential energy. What happened?
So why?
I'll tell you why. Because look, that energy was there because it was being attracted. Okay. If let's say you wanted to go there, now when you reach the place, the potential energy is lost. The same way these guys have potential energy. Now when they go to the other side, they lose the potential energy. Does that make sense?
Yes.
Yes.
Because when you travel, it takes energy to travel. So that energy is lost. Okay, fine. Now, okay. Now this is called electromotive force. What is it called?
Electromotive force.
Electromotive force. Write the definition. Electromotive force is basically first write the definition. The maximum potential difference of a circuit. That's one thing. Fine, electromotive force. And another thing you should realize is this is chemical energy to electrical energy. What is happening? Chemical energy to electrical energy. The another one is called potential difference. We know that. This is called EMF as well. And potential difference is called PD. PD is the work done per charge. We've written that already. Work done per charge. And this is electrical energy to other, let's say, other forms like heat, light, etc. Right, just tell me when you're done. Finish writing this, tell me when you're done. Finished?
Yes, sir.
Sir.
Now look, we know what these things are. We have the definition. Najla, read the definition of electromotive force.
Yes, sir.
Read the definition of electromotive force.
The maximum potential difference of a circuit.
Okay. Maximum potential difference of a circuit. And the rule, Diana, read.
Rule EMF decreases after battery is in use because energy is lost in heat, light, etc.
So Maya, read potential difference. What is potential difference?
Potential difference, PD, work done per charge, electrical energy to heat energy, light, etc.
All right. Electric. Just add one more thing. Put the word converted in both of these. Chemical converted to electrical energy converted to heat, energy, light, etc. And chemical energy converted to electrical energy, etc. Done? Now let's look at this right here. Now, what did I tell you? That they had potential energy right here, right? Now, where do they get this potential energy from? If I imagine this to be a battery, what is this? A battery, right? It has positive terminal and negative terminal. Is that clear? This is my
Yes.
battery. Now, this battery is giving these guys the energy, the potential energy. What is it doing?
It's giving them potential energy.
So inside the battery, we have something called chemical energy. What is it?
Chemical energy.
Because inside the battery, we have chemicals, right? Chemical gives energy. And these are getting potential energy. This is called electrical potential energy. What kind of energy?
Electrical potential energy.
And inside the battery, we have chemical potential energy. So both of these are potential energy. Potential basically means energy of which allows you to move, right? So now what's happening is chemical potential energy is battery is giving it to these guys, and which is being turned into electrical potential energy. Now, when they go from here to here, when the electron which from here goes to somewhere else, let's see, it takes all the energy from here and goes to the other side. But when it reaches this side, it loses all the energy. Now, where does this energy go? It goes into the it is lost as heat. What happens? Lost as heat. Now this heat is what you feel. Have you ever touched some electronic device like your mobile phone? It gets hot after some time.
Yeah.
Or a light
Wait.
bulb.
A bulb, yeah, just like a bulb, right? A light bulb. Why does it get hot? Because if I make a bulb right here, the electrons go through the bulb and release energy. And this is seen as light. This is seen as heat. Now this part of the is called electrical potential energy to light and heat. That's this part. All right. Now, since we know that electrons want to balance, right? Now, if I balance electrons, tell me, how can I balance electrons on both the positive and negative terminal? Quick.
Make the number of electrons equal.
Yes.
Equal. So what will I have to do? Will I have to take this guy to the negative side or one from positive? What should I do?
From negative to
One from
positive.
the right to the left.
Right to left. So I take, let's say I take one of these guys. There, and I remove this. Now,
It depends
is
on
it
the
balanced?
question, right?
It depends on the question, yes. Now, is it balanced now?
Yes.
Yes.
Now, will the, okay, now what happens if it's balanced? Then slowly, this energy that they had is decreasing. What is happening? They're decreasing. Because now since it's balanced, these guys don't want to go to the other side. Let's say there's one more now over here. If I say there's two more on this side, they have less energy now because one has gone there already. Now, if I make one more to go there, how do I balance it now? I can balance it by taking one more to the other side, right?
Yeah.
From left to right, right to left, and this is what's left. But now what happens is, since the electrons are now equal on both sides, will the electrons want to move?
No.
No. If they don't want to move, then the bulb will stop and the battery will be finished. What will happen? This is called battery finishes. And the EMF becomes, the potential difference now is zero. How much is the potential difference now?
Zero.
That is why after some time, the battery becomes finished, used up, because electrons travel to the other side and all the potential energy is now, there's no potential energy, done. That's my thing. All the energy is done, finished. No more energy. So you only have energy as long as the electrons are not same on both sides. When they become same, it becomes equal. And what happens? EMF decreases after battery is in use because energy is lost in heat, light, etc. And it's also lost in going to the other side. Is that clear?
Yes, sir.
Yes.
Now that's it.
Yes.
So that tells us why the battery finishes. But all you need to know is, I'll ask you a few questions, like a quiz. Let's make it two teams. We have Najla and Diana and Sumaya and Lula. Actually, no. Let's say we have Najla and Rana, Diana and Lula, Sumaya is alone. Are you ready?
Yes.
Yes.
All right, I'll ask you a question then. What kind of change in energy is electromotive force?
Do we answer here or in the chat?
Say it.
Can you repeat the question?
Maximum potential difference of a circuit.
Okay, I'll tell you. The question is, what change happens? What change happens to energy in EMF? Answer in the chat.
Sir?
Answer in the chat. What change happens to energy in EMF? Let's just say what energy change happens in EMF.
From chemical to electrical.
Chemical to electrical. All right. All right. So the first one, now you have to write it in the chart. All right. Now, the next question, the answer must be in the chart. All right. So Sumaya gets 1 point, and Diana gets 1 point. Najla,
Wait,
Rana
who has
have.
to answer from our team? Me or her?
Rana has to answer. Now you
Okay.
guys can talk between each other if you want. Now Diana and Luna, Sumaya is alone. Next question. What this question is on for Najla and Rana. What is potential difference?
رنا،
أيوة.
شايفة هذا اللي على جهة اليسار؟ أقصد يمين.
The others answer in the chat.
على اليمين
أيوة، اقري له اللي فوق هذا اللي في المربع.
حق إلكتروفيل
اللي يقول potential difference وهذا. شفته على جهة اليمين في المربع.
أو يعني
يا.
أقرأ هذا كله.
أيوة اقري له اللي فوق.
Now I've gotten Sumaya, where's your answer in the chat? Rana, what is potential difference?
Potential different BD work done per charge electrical energy equivalent to heat energy light.
Etc. Next question to, let's say, next question is to Diana and Lula. The question is, why does EMF decrease after some time?
Can you repeat?
Why does EMF decrease after some time?
Do we say here?
Yeah, say, yeah, you have to say it. Others have to write in the chat.
The EMF decreases after battery is in use because energy is lost in heat and light.
Heat. Energy is lost in heat and light and some other ways as well. Okay, then that's correct. That's fine. 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 Lost in heat. Was that Najla who answered? Yes, Najla answered. Sumaya, where's your answer?
I didn't hear the question properly.
Question is, why does EMF decrease after some time?
So should I answer here or in the chat?
Say it.
Because the heat energy is passed out, so it decreases.
Yes, that's correct. So energy decreases because the energy is lost as heat. That's what we need to know. Now let's go back over here. Did everyone write this rule? Which was current is same in series? Check if you have written this.
Yes, sir.
Now
Yes,
please
sir.
make a diagram right beside it. A small diagram, you have to draw it right beside it. Make two bulbs like this. What we realize is, let's say if I make 2 bulbs and I make another bulb right here, bulb A, B, C. And if I tell you there's another battery is connected. Okay, now you have to tell me, you have bulb A, you have bulb B, and bulb C. If I tell you the current in bulb A, or let's say in bulb B is 2 amperes. So how much is the current in bulb C?
2 amperes.
Wait, repeat the question.
The question is, or add one more thing to the rule. Current is same all around circuit. Then put in series in bracket. So Maya, are you writing?
Yes, sir.
Current is same all around circuit in brackets in series. Yeah, Lula finished?
Yes, sir.
Okay, so if I say current is 2 amperes in B, then that means current is also 2 amperes in C. That means the current is also 2 amperes in A. Does that make sense? So the
Yes.
current in A, B, C are same. If I make another one over here, what is it in D? What is the current in D, Najla?
2 amperes.
Because it's all same around the circuit, but it must be in series. That is afterwards. We'll look at what series means in a second. So let's look at PD around a circuit. Now we'll first look at series. Series circuit. Write this and we're done with the whole current thing. Series circuit. And we'll write something called parallel circuit. PD slash voltage. PD voltage are the same thing, by the way, exactly the same. Just nicknames of the same person, right? They thought, why call it P potential difference? Because you have an easier name, voltage. Now, series circuit is, let's just say, connected side, end to end. And parallel circuit is connected side to side. Write this, tell me when you're done writing.
Done.
Done. Now we have series. Okay, connected side to side. Now, okay, what does that mean? Well, if I have a circuit like this,
I think it means that in a series, the energy will flow. It won't finish. But if it's parallel, side to side, if it finishes, it will use both the sides and it will end.
not really, no. That's not what it is. I'll tell you what it is. Just a second. Now, if I have something, let's look at bulbs, okay? Now this is a bulb. Can you tell me where is the end of the bulb? The side A and B, right?
Yes.
If I add another bulb right here, Rana, focus. You have these, another bulb. What are the ends of these guys? This is B and C. No, not B and C. Let's say C and D. Fine. Now, are they connected end to end? Each end is next to each other, right?
Yes.
This is called end to end. That means it's in series. So if I make current right here, or well, in series circuits connected end to end, please write right below it, right? Voltage. Voltage in series. Then write current in series. Voltage in series, first write current, which is going to be in series is same, but voltage is shared. What does that mean? Well, if I have a battery right here, the battery is 5 volts. How much?
5 volts.
And if this one is 3 volts, how much will this one be?
3 volts.
No, it will not be same, because now we're looking at voltage. Voltage is shared. Okay, so we'll just say voltage in series is shared. And let's just say voltage is shared in series. Current is same in series. Now that means is if I have voltage, voltage is a bit different. So voltage, if I have 5 volts, that's the total. What is it? That's the total. Now over here we have 3 volts and this must be 2 volts because these must add up to become 5 volts. Is that clear? That's example 1. Now if I say the current in this guy is 5 amperes, can you tell me what is the current in this guy?
5 amperes.
Because they are same. Current is same, but voltage is shared. So may any doubts? Najla,
No, sir.
No,
right?
sir.
Another exam diagram right below it. And it's your job to tell me the answers. All right, now tell me in this one, you have 7 volts right here. This is 10 volts. How much is this? X. Quick, hurry up.
Who should answer?
Anyone. The one who answers first is better.
3 volts.
3 volts. Najla is better. In this question, 3 volts. Now, if I tell you the current is 2 amperes in this, what is the current here?
2 amperes.
2 amperes.
2.
2 amperes.
2 amperes. So that makes it easy for everyone. Now let's look at another one. Another question of not this one. That's done. We look at parallel circuit. Current is shared in parallel, and voltage is same in parallel. So if you have a circuit like this, now first let's look at the circuit actually. Now if I have this bulb right here, the bulb is right here, and I have another bulb right below it. Now are these bulbs, tell me, connected side to side or end to end? Just a second, they're not connected yet. Are these bulbs connected side to side or end to end?
Side by side.
Side to side, because look, this is the side of it. So side to side. Make the diagram as well. And what we realize is this thing right here, this is called a junction. What is it called? Just write this, it's called a junction, where you can divide the circuit into 2 parts. Now, if I tell you that this is 5 volts, or let's say this whole thing is, or let's say this whole thing is 6 volts. Can you tell me what is the volts on this? The second bulb?
3.
6 volts.
3.
Not 3. Why? It must be 6. Why 6 volts? Diana, read the rules quick.
Current is shared in parallel. Voltage is same in parallel.
So do you realize that they must be same in parallel? So if this is 6, this will be 6 as well, right? Now, if I tell you that over here at this point, let's say point F or point K, the current is 10 amperes. And the current on this for the first one is, let's say, 2 amperes. Then what is the current on the second one?
2.
Now, what is current? The shared. And the total current is 10, and this guy has 2. So what will happen here?
8.
8 amperes. Why is that? Because when this current goes over here, it's shared. So 2 goes up and 8 comes down. Is that clear? The current is shared. 2 goes up, 8 comes down. We'll look at this in the next question in class as well. Now all you have to do is draw these diagrams. Not that diagram, not that diagram, just a second. This diagram. Now if I have, over here I have I1, current 1. Now from here I'll get 2 current. These will be called now 2 current, which will be called I2 plus I3. Okay. And just write over here, which is I1 is equals to I2 plus I3. In this case, all you have to write is write V1 or V2, V3. Write this as 1, V1. Write the equation V1 is equals to V2 plus V3. Write this, tell me when you're done. That's it. So Maya, what are you writing right now?
I'm writing I1 equals to I2.
This is the total voltage. And this is the total current.
We're done, sir.
Diana, have you finished writing?
Yes.
Then that's it. Now we look at, we finished potential difference completely. We'll have to look at something else in the next class. Let's see what that is going to be. That is going to be, now, you know, quick, just one question. Whoever answers first is clearly paying attention in class. What is the formula for voltage?
W by Q.
W by
by
Q. Good job. All right, Shana, good job. Now, so we have that. The next class, everything is done in voltage. Next class, we'll have resistance. And then the chapter is done. Resistance and resistivity. Lula, recap. No, not Lula. Sumaya, recap. What did we study in this class? Quick.
We studied potential difference, the EMF, and PD. Yeah. We studied the potential difference of around the circuit, a series and parallel circuits.
Circuit. So that's it. Potential difference voltage around circuit, PD voltage and current around a circuit, basically. Because we're also talking about current here. In series, current is same, voltage shared. In parallel, opposite, current is shared, voltage is same. That's all for now. Take care. Goodbye. We'll study. See you tomorrow.
Thank you.
Thank you so
Bye-bye.
much. Bye.
Yes, sir.
Bye,
Bye.
sir.
Diana, can you hear me?